Hello, everybody. I'm going to talk about transformations of functions today. So I'm going to use the parent function square root of x as an example of how to transform a function. We're going to study the four main types of transformations and talk about some significant transformations within each type. All right. So let's start with a vertical shift. All right. So this is my function. I'll move myself out of the way. All right. So if my function is the square root of x, it looks kind of like a half parabola on its side, right? A vertical shift is basically going to move my function up or down. So if I want to create a vertical shift, what I'm going to do is how do I get myself out of the way? There we go. You don't need to see my face. So um, to create a vertical shift, all I have to do is add or subtract the value to the entire function. All right. So for example, here I'm adding or subtracting 0, so it's the same function. But if I were to add 2 to this function, for example, the function would move up 2 units. If I were to subtract 3, well, you see that the function has shifted down 3.1, negative 2.9 units. All right. So to move a function up or down, all you need to do is add or subtract to the, it is recording me, okay, to the entire function. All right, so for example, this function would say square root of x minus 2.9. Okay, very good. And that's a vertical shift. Okay, a horizontal shift. Horizontal shift is going to move the function left and right. So to move a function left or right, you simply need to subtract an amount or add an amount to the argument, to the input. Now this one works a little funky. All right, let's say I were to subtract 1 from my input. If I were to subtract 1 from my input, this would move my function 1 unit to the right. If I were to subtract 2, remember I'm saying subtract. If I were to subtract 2, it would move it 2 units to the right. If I were to subtract negative 1, in other words, if I were to add 1, then I would move 1 unit to the left. If I were to subtract negative 3, then that would move me 3 units to the left. Okay, so let me show you what this looks like in action. So if I've moved this function 3 units to the left, I have graphed the function square root of x plus 3. All right, notice how that is the same graph, square root of x plus 3, because I have essentially subtracted negative 3 from the function. All right, notice how if I say square root of x minus 5, that shifts the function 5 units to the right. All right, a little bit different. Very good. Okay, so that's the horizontal shift. All right, now let's get to some cooler transformations, vertical stretches. So to create a vertical stretch, what you're going to do is you're going to multiply a number to the function. So let's say I had, for example, 4 square root of x. Notice what happened. This function is what you call 4 times taller. It has been stretched by a factor of 4. Okay. So you can see right here that the larger I make my a value, the more the function stretches vertically. The smaller I make my a value, the more it compresses. And then check it out. If I happen to have a negative value multiplied to the whole function, then that would flip me across the x-axis. You'll notice if I make this negative 4 to the x, it has now been reflected across the x-axis. So that is the a value, the vertical stretch. Okay, and finishing up with a horizontal stretch. So horizontal stretch or compression occurs when you multiply a number to the input, to the argument. So you need to be able to tell the difference. Is your value being multiplied to the whole function or just to the input? All right. So here's a b value of 1, in other words, the original function. But check out a b value of negative 1. All right. A b value of negative 1 would completely flip this function across the y-axis. Okay. A b value of negative 2. All right. Take a look at how that stretches or compresses. So the larger I make my b value, actually, the more compressed this becomes. It looks like it's getting taller, but this is actually compressing the function horizontally. All right. What looks like a vertical stretch is actually a horizontal stretch.